In this video then we're going to take a look at how to test if something is a maximum point or if it's a minimum point. So we looked at this in the last video here. We had our blue parts to that graph were positive slopes. The green part then in the middle was a negative slope. So what we're going to do just to kind of figure the idea of this is we're going to change those pluses just to be real numbers, just so you can see how the maximum and the minimum works. And the same with the minuses. We're going to change them into be proper numbers. So again, I'm making these numbers up, but if we need to get back to a slope of 0 here, and this is a positive slope, what I could have is I'd have a slope of 3, a slope of 2, and a slope of 1. And with those slopes, it's because I know that the slope is positive, but I know the top is 0. And I know that I can see here that it gradually at this stage gets less and less steep. So the slope is decreasing. And if you go to the green, I'll have a -1 because we're now in negatives, -2, -3. But eventually, knowing that I have to get back to 0, I'm going to have to do -2, -1, and I'm back at 0. And then over on this side here, I'm back doing a 1, a 2, a 3. And again, those numbers are made up. It's just to kind of have an idea of what the numbers are. I'll get rid of these bits in the middle just so we can see it a bit better. So they're the slopes, and again, they're made up slopes, but it's the idea we're looking at here. Now, when we're doing stationary points, maximum points, minimum points, like we did in the previous video, what we're talking about there is we're talking about for turning points, maximum points, minimum points, stationary points, we're looking at our first differentiate equaling to 0, first differentiate equals 0, first differentiate equals 0, because we're finding these two coordinates here, and that's what we know our slope is at those points. For turning points and stationary points, we can be asked to determine which one is which. And for maximum point, we know this specifically is the maximum point. It makes an N shape. And this is a minimum point. It makes a U shape. So what we do to test which is which, we use the second differentiate. Now we know from the last video, we have our original function. If I want to find the rate of change of the function, I get the first differentiate. And that is the slope. So the rate of change of the function is the slope. If I get the rate of change of my first differentiate, it's called f with 2 dashes and x, and that is how the slope is changing. So how the slope changes, and we're going to use that idea to help us test if it's a maximum or minimum. So looking now just at the numbers at our maximum point on our graph here, these numbers here surrounding it, I can see at my maximum, the 0 is in the middle. So there's my 0 in the middle. And I'm just using these numbers here. I can see it goes 3, 2, 1, 0, -1, -2, -3. That's how the slopes go. So ignoring the fact that it's an N shape and just looking at the actual slopes here, as we go from left to right, we can see that those numbers are decreasing. So what is my slope doing? The rate of change in my slope is negative. So my slopes are decreasing. So the first differentiate is the graph is increasing and the graph is decreasing. The second differentiate is my slopes are decreasing. And if I'm looking at how the slopes are changing, it's my second differentiate. And here, my second differentiate is decreasing, it's less than 0. So that's how I test to see if something is a maximum. I do the same thing if it's a minimum. So if we have a minimum, and again, I go with the numbers that I have here, I'll put my 0 there in the middle because I'm checking to see around this coordinate what's happening. And I'd have -3, -2, -1, 0, 1, 2, 3. So if I look again at just the numbers in those slopes, not at the fact that that graph is going in a U shape, looking at how the slopes are changing, I can see those slopes are increasing because they're going from negative numbers to positive numbers. And if I'm looking at the slopes, the rate of change of the slopes, that's the rate of change of the slopes is the second differentiate. The second differentiate is greater than 0. So that's where we're getting this information underneath here. This information underneath here. So to prove whether something is a maximum point, the second differentiate is less than 0. And that's where I'm getting this from here. To prove a minimum point, the second differentiate is greater than 0. And that's what's coming from here. So it's nearly the opposite than what you think. For a maximum, it needs to be less than 0. For a minimum, it needs to be greater than 0. Because at a maximum, the slopes are going down in terms of numbers. In a minimum, our slopes, the numbers of the slopes are actually increasing. So now that we know that, to test and see, all we do is we get the second differentiate and fill our x coordinates in. So now let's take a look at a question on that. So if I take a little look at this one, we looked at this in the last video as well. We're now going to look at this last little section of it here. So we have our graph here. We have found the turning point, the stationary point. Here are our two turning points and stationary points here, the 1, 4 and the 3, 0. We need to test and see which is max and min. Now we can see from the graph which is the max and which is the min, but this is again using the information we're given. We probably won't have a graph when it comes to actually doing these questions. So it's good to see it from the graph and see that our answers make sense. So to determine the nature of the maximum and minimum points, what we do is when we need to get them first, and we know they are 1, 4 and 3, 0. They're my two coordinates. One of them is maximum and one of them is minimum. Now how we test is we test using the second differentiate. Now we have our original function up here. Our first differentiate we have over here as well. So I'm going to write down our first differentiate. And our first differentiate, that found us what our slopes actually were. Now we're testing which is which. So to find the rate of change of my slope, I get my second differentiate, which is 6x minus 12. And I'm going to use the coordinate 1, 4. And I'm going to use the coordinate 3, 0. Now, if I'm using the coordinate 1, 4, I only have place for the x to fill in. So I'll end up with my second differentiate. I'll move this down a bit. My second differentiate, I'm going to sub in 6 times 1 minus 12. I don't need to fill the 4 in because there's no place for a y coordinate here. So I'll end up with 6 times 1 is 6. Take away 12. That's equal to minus 6. And I'll do the same with this number over here. Here, my x coordinate is the 3. So I'll do 6 by 3 minus 12. 3 6s are 18. Take away 12, I'm left with 6. Now, the numbers, the minus 6 and 6 don't matter. What matters is that this is less than 0 and this is greater than 0. Now, if my second differentiate is less than 0, I have a maximum point, and that maximum point is 1, 4. If my second differentiate is greater than 0, therefore I have a minimum point at 3 and 0. And if we check our graph on the top, our minimum point is the 3, 0, and our maximum point is the 1, 4. So when you're asked to do a question like find your stationary point, find your turning point, you only need to find the coordinates. If you're asked to determine their nature or find a maximum and minimum, you have to follow the 3 steps. So you're basically doing these 2 questions all at once. So the 3 steps would be, the first step would be to get your first differentiate and equal it to 0 and solve to find your x values, okay? So here's your first step, which is what we did here. Got our first differentiate, equal it to 0, and we found our x values. Our second job then would be to fill our x values into f of x. Why? That will find us the y coordinate, okay? And that's what we did here. So there was our step 1, there was our step 2. Our step 3 then is to determine if they're max or min. And how we determine their max or min is by filling in our x value into the second differentiate. And that will test for max or min. So they're the 3 steps. And this is probably the most asked question in calculus. So we'll make sure that you know those steps and that you have practiced those, because they're really, really important. You have to get your first differentiate equal to 0, get your x values. Fill the x values into the original to get your y coordinate. And then you have the 2 coordinates. You need to test which is max and which is min to determine their nature. Use your second differentiate to test if they're max or min. Max is going to be less than 0, min is going to be greater than 0.